Hello, everyone. Good afternoon. This is Arshad. So let's look at this $15.7 trillion economy. This is focused for 2025. So $1.2 trillion is going to sales and marketing. What does it mean for people who are practitioners? It's automation. Automation of content, automation of flow, automation of fine-tuning, the content coming out, going into the systems. Software engineering has changed forever. We thought in the beginning that there will be most job impacted. It's the other way around. It's more valuable than ever. All we need to do is pivot to the concept of this large language models, how word embedding works, how LLM works, how to get into Hugging Faces, all those things. There are pre-trained models which can be consumed, and startups have one of the best opportunities. Other function, $1.1 trillion, which is supply chain management, automation, everything is changed. Research and development and customer operations. This is who we are. Our credibility has been proven upon time. Biggest clients have been US Navy and General Electric. On the B2C side, which is education, we have been top rated multiple places, and we have been in business since 2015. This is a very diversified team I have. We are based in Irvine and Orange, where I sit personally in the Orange office on Barranca Parkway. So if you're local, you can stop by and meet us. These are some platforms we have built as an AI company in real estate, fashion, medical, and edtech too. So now let's look at this. Where is the biggest opportunity shift? I think healthcare is big time impacted in terms of now we are able to. The biggest challenge in healthcare, in my point of view, I'm not a healthcare expert, was the data. And how do you bring it? How do you train it? How do you get to the accuracy level? That all has changed with semantic and synthetic data generation, which is another topic to talk. Real estate, we have done evaluations ourselves, land, residential, commercial. So that is a little bit slow industry. And EdTech, I think, is fully changed. On the job creation side, the opportunities have increased a lot in AI field, for sure. But what are those opportunities and how to pivot to it is the question. Job transformation is 20%. So overall job market is impacted more than 55%. 10% is skill development, new people trying to learn this technology. I'm seeing every kind of people coming to webinar and our events. If you are a data scientist, these are your impacts level. Analytics, machine learning, everything has been shifted a little bit. Approximately 30% impact on the whole scenario. I wanted to talk about this topic which I'm observing. There's a demand and supply ratio. We interview a lot of people throughout this process in terms of B2C, B2B, and also hiring for ourselves. Demand and supply ratio has crazily changed. I'm no one to say good or bad, but what we are seeing is, I can tell you, is skill level and awareness is there, but now the transition has to happen to adopt to the new OpenAI concept and find pre-trained models and all those things. So it's big. That's all I'll say. We introduced a transition product. Though AI data science for professional has been existing for 5 years, we refocus this whole product and call it Refocus on Generative AI, large language models, with some causal interface, auto ML. So it's very advanced program. We repurpose it. So it's what I call transition program. How to work with us? We have B2C model, which you are now seeing me doing it, where we host workshops, webinars, bootcamp style teaching, and all those things. This is the first level. Second level is B2B model, where we do prototyping, modeling for startups, and research and development, whatever it takes to draw the roadmap. This is one phase where we are very passionate about, since we are ourselves a small, mid-sized company. At the same time, very passionate about integrating AI with different fields. This is our preferred model. All these platforms which you saw are built in this model, which is where we do a joint ventureship with partnership with, let's say, healthcare company, real estate company. They know their game, we know the AI game. And we also play as an investor in this. Now let's look at it. How do we combine all this thing from an architecture point of view? What does it mean? So I brought this one which is no way a perfect architecture, but also gives you understanding of how to combine now machine learning experiments with large language models, how to get into lemma index, LangChain, and how do we now build systems and apps and all this thing around it. So we talk about the first thing is prepare, select, evaluate that you've done, get your model, adoption, validation, deployment, and now you have to do some kind of a prep transitioning work to tap into large language models, prompt engineering, choose the domain, select all those things. This is just a sample. So you transition from your current, and that's what we did. We have real estate, we have healthcare, we have edtech, all this are existing product. We are transitioning into tapping into large language model in general. Chat is enabled. Someone was typing. I have sent the open link to everyone. Okay, so let's move on. So if you are already a practitioner in machine learning space or data analyst, someone who is trying to do it or has done it, the connecting piece is what I'm showing here. So after you're done with your basic experiment, I've been doing this as a professional for almost 10 years as an entrepreneur. The biggest challenge throughout this process was data. Fine-tuning the data, bringing new data. Machine learning takes like 3 lines of code technically. The pre-work and post-work is the major work. So that's where this architecture helped us to get connected in prompt engineering, which is tapping into large language models and doing those things. Now, credit card fraud detection was a topic which was published, and the experiment is around that, but I did not build the model. Modeling is machine learning. What I did is how to connect into large language model and how to make it live and all those things. But this problem has stolen credit card details. This is from fraud.net. I just got this image available for, that's the sales switch. 45% of credit card users are reported having 2 or 3. I went through first fraud in 2015 of 30K or more. People in their 30s are most vulnerable for credit card fraud. So 45% user are impacted. So this problem is causing billions of dollars, and we know about credit card fraud, so I don't need to define the problem. It's a serious thing. Let's look at how do we approach this from the large language and semantic data and AI integration point. So I've broken down this into steps. First is data processing with LLM. The second part is anomaly detection with generative AI, and third is how these are the 3 steps we'll build this real-time fraud alert system, which banks are already using it to an extent. Wells Fargo always sends me messages which I use it, that we got this transaction, is it yours or not, those kind of things. I see a message here. So step number 1, there are 3 steps. It's broken down: data processing with LLM, anomaly detection with generative AI, and real-time fraud alert. So we'll take in data processing, transactional data, those purchase locations, fed into LLM, step number 1. Step number 2 is understand the pattern, anomaly of the nature of the data, and recognize the value. So that's what we are going to do. And anomaly, step 1 is to historical fraud data. And then from there, we are going to see the potential fraud learning patterns. And the third will be redefining the detection of the algorithms. So we'll look this into detail. So this is step for fraud detection. So when you tap into, these are like for new people, ChatGPT has some transformers and tokenizer. I'll talk a little bit about transformers as I go. And tokenizer is the response if you are new, which comes in the ChatGPT is 1500. That's the number of the tokens it breaks down its response into. So every sentence you throw into the large language models, they are converted into a vector and further into, we call word to vec, into tokens. So that's what I'm importing here. And then from there, I'm going to ChatGPT 2. You can go to 3 and 4, latest one, and try to get something, tokens and models out of it. This is a model I'm connecting, and these are the parameters I'm passing. Purchase amount 1200, for example, location, timestamp, and the category type is merchant. And then from there, I'm doing some pre-text translation here with tokenizer and encoder and embedding it into the model. So Second step is what we are going to do is take this interrupt LLM output analyzer, and you can drop in your questions, so we can, Ethan is drop in. There's another one there. I'll take all the questions, but please keep pouring it there. So while I'm speaking, I can, articulate in my talk too. So that will be good. So contextualization of data with LLM. This is what we are doing here is we are trying to get some output from large language model and the step here is to response inside flag. This is a natural language process technique. We'll see more detail here in next steps. Now let's talk about anomaly detection and how it's broken down. So step number one is generate a model on the historical data. And what we do here is generate model, learn from the create, mimic real fraud transaction. So there's two concepts involved here, semantic and synthetic data, which I'll touch. That will clear this up. And then you have two kind of GAN models as discriminator and generator. And I will give you a little bit more insight. So discriminator model learns from distinguish between real and synthetic data. And generator model will create a fraud case hypothetical so it says that it will create a data that mimics the real fraud transaction, and discriminator will say this is not a fraud or this is a fraud. Over time, generator will better perform and then producing a realistic fraud situation, and then the process will be completed. So this is how you do it. If you haven't done a deep learning, this may not make sense for you, but just try to understand from the high level point of view. The generator is something, GAN models, this is what is behind the chat GPT or pre-trained models. What that two neurons. Generator is the one which take a hypothetical situation that this is the fraud case and give to a discriminator second neuron which is trained on two things: to identify a fraud, real fraud, or hypothetically reject it if it is not a fraud. So it knows the real value is distinguished versus true or fraud. But let's say you made a hypothetical situation for a 3-year-old kid trying to make a fraud. Gustavo, I'll get to your question. Thank you for posting here. So for hypothetical, a 3-year-old with using laptop try to create a fraud was generated by a generator. Maybe there are some 3 years old who can do it, but in conscious mind, I don't think that's maybe 0.1%. So discriminator is trained to identify just on what a 3-year cannot do it. So what it will do is it will reject the use case and send it back with a penalty. Penalty means loss function. So what generator will do now is understand this and say, maybe I need to change this to 13 years old and keep everything else. Now discriminators make sense. And if says that it was done in some part of the world where there's no electricity or internet, maybe I'm just making up something to explain you the difference. Technically, this is what it does. There are layers in the neural network. So here I'm using the Keras model with RLU function and activation. So first it's building the generator, and then it's building the discriminator here with symbiote function. Now, what we are going to do is, the next step is redefine the detection algorithm. So what I'm trying to do here is basically conceptualize, retrain, and fine-tune the model updates, and with the detection of real transaction context. This is just simple pre-processing. Now, redefining the detection algorithm, it updates a new insight from large language synthetic data, and then from there machine learning technique will fine-tune the model into new pattern, and that's the two things we'll do. Now GAN will be challenged to issue a model carefully monitoring and data converting transaction to format suitable to AI models, and those are the things. And the last thing we'll do is integrating and testing of it. So real-time fraud, how do we build that? In this system, code representation of high-level view of continuous monitoring transaction, sophisticated algorithm detection. So this is what are the key features required here. And then financial service of preventing fraud and customer practical applications of worldwide settings. So this is what we are doing for monitoring purpose. Live transactions are recorded, and then fraud detection algorithm, detect.algorithm, which I did not put the right one, is executed, and then generative explanation of the transaction and trigger the live transaction activity when you get those alerts. 2-3 frameworks. One of them is LangChain and Llama Index, but there are a lot of other frameworks too. And Hugging Faces, if you guys don't know that, I'll explain you a little bit. So LangChain is a framework which allows you to tap into large language models and chain multiple large language models, do some vectorization, do some word embedding, and tap into to push and pull the information and customize it. Llama Index is a little bit, it can take your input, even LangChain can take it, not only Llama Index, but which, like, let's say you're a law firm or a bank or a healthcare company where you have tons of records and you want to use your existing data, which can be a bunch of PDFs in terms of law firm, and take that information and tap into large language models, and maybe you want to find hundreds of cases similar to what you already have it. So you can customize your base data, which is your organization data, and do some prediction, then get into large language models, fine-tune them, bring them back, and make some prediction or systems out of it. So this is what the big framework is. So this is how you do it. You do something called transfer learning, fine-tuning, safety mitigation, and distillation. These are advanced concept. Transfer learning is you train a neuron network, pass one weight to another neuron network by transfer learning. So a couple of steps involved into is tuning, distillation, row ranking, embedding, compact embedding involved reducing the dimension of input and output in word embedding in LLM. Then architecture change, as I showed you, and parameter sharing. So these are the steps when you go it. Again, I'm talking at very, very high level, literally at definition or a little bit definition, below definition level. Semantic data, which I've been using this term a lot. What is semantic data? And we did semantic data in terms of generating the fraud data, which I gave an example of 3 years to 13 years. Semantic data can be understood in a very simple way. I explain it. Imagine a musician, right? One guy is playing a guitar, another is a beat, another is a drum. That's what, if you mix all three, that's called semantic data. You created something new based on 3 tunes generated. So in the AI term, it's a database which has added some semantics and smoothen the integration. So the way you do it is link the data, knowledge graphs, and semantic annotation in research paper, which is how do you combine this into graph models? How do you make sense out of integrating this data? This is what the GAN look like. Takes 1 hour to mathematically explain, but this is what is happening behind a large language model. There's encoder, and the next side is decoder. So input is provided, some vectorization happens, some attention mechanism is created, and then from there, in this decoder pass the input to the encoder, pass the input to the decoder, and it takes the last layer of the input and goes on to continue from there. Encoder, decoder is again what generator and discriminator, what I was talking before. So this is, you can explore this. This was the original paper which is behind the open AI. Semantic data generation. So synthetic data generation and semantic data generation. Synthetic data generation is what I said about music. There's a real beat, there's a real drum, and there's a real guitar. Synthetic data generation, which we have been doing, I used to call computational data generational. So if you have a matrix of, let's say, 16 by 16, you can look at just one dimension, 16 by 16, the data into 16 to the power of 16. So what you do is you take computationally that data set, a table, and change few statistical rows and columns and generate more data out of it, which will be very similar to what if you collected the data. So in here, what we are doing is again showing the same part, generator and discriminator. Original generator, assume a noise, which is an imaginary something, and said, okay, I'm going to synthetically generate it. Discriminator said it's not true and gave them a mix of this, and a new data is generated out of it. In image generation, this was just a vector created with maybe there was pre this image, there was a just set of numbers. Discriminator said, oh, does not look like human, change something, generator change it. Discriminator kept giving the loss function. Towards the end, a human being is created, which is not true. So now the fake images are created very much like this. If you look at them very carefully, left and right do not match most of the time. I did not spot it, but this left person looked totally different than, see, this eyes is different. But bottom line is, discriminator and generator with competing with each other are able to give results like this. We use it in one of our app, which we built. It's a makeup app. And we had 25 images for the woman makeup. We cannot train AI on 25,000. So what we did is we took one face and generated multiple faces with it, with multiple makeup types. That's our team. I'm in this office in Orange. We do host sometime in-person events, so you guys can jump in there. If you have further questions, you can reach out to my team and put up some appointment there. This is the team behind it. I'm in the middle, and my chief scientist is 5 masters, postdoctorate. Nan is PhD in economics and machine learning. These are few people who have gone through our programs. The program which I was talking to you about is this one. It's very comprehensive. It's a market shift program. You come with basic understanding of whatever you are. If you're not, we build you up. From there, we go further in exploring, making those things. Causal interference, if you don't know, just Google it, you'll know it. This latest trend, we do error reduction. Now, causality is the reality where the real things happen. So we brought that. Do YML, causal ML, those things are brought here. And then you build advanced machine learning models with us. And then you get into large NLP, which is the base of large language models. OpenCV, NLP, deep learning models are covered here. Then you do a real application. And then there are project days, which are very heavy. This is 5-day program, full time. We run it on a weekend format and full day also. Continuous, depend upon where you are. And all you do is hands-on work. Last day is dedicated to bring your own project. If you like to experiment or you are a startup, we'll help you to do that. So now I'll take the questions. Ethan, using LLM, a novel approach to compare the traditional classification model like RF. Is it a new trend? RF is reinforcement learning, Ethan?
I was actually referring to random forest. Your traditional classification, the classification models like random forest.
Oh, random forest.
Yeah.
So what is your question?
No, I mean, this is the first time I've encountered or come across using the LLM, the neural networks, for fraud detection.
Yeah, depend upon use case, what you're trying to achieve. But for us, the shift was, we have enormous opportunity to tap into it, get some synthetic data, use it, and also evaluate it. So that's why I personally go that way. Our company is moving that side.
And actually, that might answer my second question, because I was trying to decipher the inputs into the sequential model that you had put up on your screen. Are you passing in? What's your input data, and then what's the target data?
You mean on the semantic side?
Yeah, I think it's semantic data, right? That you're passing it.
Yeah. So what I do is usually do a transformer in natural language processing and vectorize it. It depends upon experiment. What is your features, right?
Right.
Yeah, so I'm not having any specific, whatever features I'm evaluating my models on, I will do a transformer and then get ready to tap into large language model. You need to do some word embedding before you go. It cannot take the way state like your data frame.
Oh, no, I know that. I realize that. But I'm trying to understand, like, how are you measuring your accuracy against? Right? So you do your embeddings, right, based off of, the text data that you're receiving, right? But then you're going to be doing a loss function against that, right? But what's the target?
Target is to improve the accuracy.
Right. No, I know, but what's your Y value? What's your output, right? Because you're going to have your training data, and then you're going to basically have your real world truth, right? Your ground truth. What's your ground truth? Is it labeled data, or there has to be something that indicates, there needs to be a pattern to say that, hey, given this combination of words, or, because I guess the data type you had was transaction time, maybe the
hypothetical. That's not that I built something real. It was hypothetical to show the concept.
right. But you see what I'm saying? If it's hypothetical, right?
Yeah. So I
Didn't
do in the facial one, which we are doing real. We are not concerned about the semantic data I get back is to increase the volume and features. I'm not the real test of that result will be when we upload the pictures of a real human who wants the makeup out of it, and it has improved the accuracy to a good level. So I'm not testing or to improve that. I'm not testing my results based on what one way to test is what large language semantic data is giving me and immediate lab results, right? The next is the customer feedback. So number wise, yeah, it has gone from 87% to 92% versus me struggling with like 75, 72%. So your Y value is outcome right now. In this case is my facial, artificially generated faces, which I'm getting back, and the count, which further goes into my open CV models to further train it. Okay, let's move on. Gustavo, so the historical data plus generative data train better in machine learning creation with the volume? The answer is yes. Gustavo, but thank you for your time. Really appreciate you guys joining. Hopefully you will be part of that transition program which we are launching. We are looking for partners, employees, everything, and hopefully we do all this thing together. Thank you.